Welcome to Collapsed Latents. This week in AI, where we cut through the noise and bring you the most groundbreaking, mind-bending research that's reshaping the future of artificial intelligence. This week, we're diving into 5 transformative papers that push the boundaries of agent learning, reasoning, video generation, enterprise automation, and most critically, how we evaluate AI. No fluff, no hype, just deep, actionable insights from the cutting edge. So grab your coffee, fire up your curiosity, and let's get into it. #1. Trace to skill, the human-like mind of AI agents. Imagine an AI agent not just executing tasks, but learning how to do them better, like a seasoned expert. Not by being told every rule, but by figuring out the patterns just like a human. Enter Trace to Skill, a framework that turns raw behavioral data into transferable, self-contained skills, not through trial and error, but through inductive synthesis. Most agent systems today either fragment knowledge into hundreds of brittle, isolated rules, or update them one failure at a time, like editing a book sentence by sentence. But humans don't learn that way. We read hundreds of examples, spot recurring structures, and distill them into principles. Trace to Skill mimics that process, but at scale. It begins with a large agent running hundreds of diverse tasks: spreadsheet manipulation, math reasoning, document analysis, even vision QA. Every action, every decision, every output is logged. Then a fleet of specialized subagents kicks in. Success analysts identify what worked, not just the correct output, but the pattern behind it. Error analysts act like forensic investigators, comparing failures to ground truth, simulating fixes, probing root causes. No sequential bias. No memory banks. Just raw, diverse, parallel analysis. Now comes the breakthrough: inductive consolidation. Instead of applying patches one by one, Trace to Skill merges all insights at once, elevating common behaviors into universal principles. If 100 different failures reveal that pandas to Excel silently destroys formulas, and the fix is always to use openpyxl, that's not a coincidence. It's a systemic truth. And so, Trace to Skill collapses that into a single, reusable skill. When writing Excel files with formulas, use openpyxl instead of pandas. No retrieval. No lookup. Just embedded wisdom. And the results? A 35B model trained on this process boosted a 122B agent's performance on Wikitable questions by 57.65 percentage points. Not just accuracy, but generalization. It didn't memorize. It understood. It learned that certain tools are inherently fragile in specific contexts. It discovered best practices, not because they were in the training data, but because they emerged from pattern recognition across thousands of traces. And this skill transferred across domains, math, vision QA, even competition-level benchmarks. This isn't evolution. It's elevation. Trace to Skill proves that AI agents can become experts, not by being told what to do, but by learning how to learn. #2. FIPO, teaching AI to think deeper, not just longer. Now let's talk about reasoning, the core of intelligence. We've seen models generate long chains of thought. But often they're just long, not deep. Why? Because standard training treats every token the same, whether it's a critical insight or a filler phrase. The problem isn't length. It's quality. Enter FIPO, Future Scale Influenced Policy Optimization, a reinforcement learning framework that redefines how we assign credit in reasoning. FIPO's core idea is simple but revolutionary: the future shapes the present. Instead of rewarding the final answer, FIPO measures how much a single decision changes the future trajectory. It calculates the future scale divergence, how much the current policy shifts the distribution of future tokens. A high positive value. That's a decision that builds a coherent, sustainable chain of reasoning. A negative value. A dead end. A misstep that collapses the entire line of thought. Then it reweights the advantage signal, amplifying tokens that sustain reasoning, downplaying those that derail it. The result? On QN2, 5-32B, average response length jumped from 4,000 to over 10,000 tokens, not just more text but deeper thinking. On AIME 2024, FIPO achieved 58% pass at 1 accuracy, surpassing both DeepSeek R10 Math and O1 Mini. And here's the kicker: no value network, no critic model, no PPO overhead. It's built directly into the GRPO framework, lightweight, efficient, and transparent. Qualitatively, the model evolved from template-based planners to systematic auditors, rederiving results, switching methods mid-chain, manually verifying steps. It's not just longer reasoning, it's deliberate reasoning. FIPO shows that dense advantage signals don't require complex architectures. They require smarter credit assignment. And it's open-sourced. The future of deep reasoning is now in your hands. #3. The terminal agent revolution. Simplicity wins in enterprise automation. Now let's shift from theory to practice, from reasoning to real-world automation. For years, we've assumed that enterprise AI agents need complex tool registries, GUIs, playwright bots, layers upon layers of abstraction. But what if the answer is simpler? Our latest research shows that a minimal coding agent, just a model with terminal access, can outperform even the most sophisticated systems. We tested 3 paradigms: GUI agents, tool-augmented agents, and terminal-based agents, all on real workflows in ServiceNow, GitLab, Next. The result? Terminal agents 1, consistently. Take one task, ordering an iPad Pro. A GUI agent hit a dead end, no tool for ordering. A web agent got lost in iframes, generating costly failed sequences. The terminal agent. It wrote the payload to a file, explored endpoints and succeeded at 9 times lower cost. Why? Because it talks directly to APIs, no fragile UIs, no abstraction layers. It explores, adapts, and learns. And when we gave it a persistent skills directory, a place to store reusable procedures, success rates jumped, and costs dropped by up to 43.7%. One skill about shell quoting. It helped across platforms. Another about handling JSON payloads in different encodings. Reused across workflows. But it's not perfect. It can't impersonate users, read rendered charts, or handle drag-and-drop workflows. So we tried a hybrid agent, terminal plus browser. With a strong model like Claude Opus 4.6, it hit 83% success on ServiceNow, the highest of any setup, while still being cheaper than pure web agents. Because it learned to route, use the terminal for data manipulation, the browser for UI interaction. This isn't about complexity, it's about expressivity, cost, and reliability. The future of enterprise AI isn't more layers. It's a quiet terminal, a smart model, and reusable skills. Sometimes, the simplest path is the most powerful. #4. ShotStream, real-time, interactive cinematic storytelling. Now let's go visual. Imagine not just generating a video, but living the story, shot by shot, frame by frame, in real time. That's ShotStream, a revolutionary approach to multi-shot video generation that turns AI into a real-time co-creator. Traditional models are bidirectional, they look forward and backward. But that means you can't change anything mid-flow. Tweak a character's expression. Regenerate the whole video. ShotStream flips the script. It's autoregressive, causal, and interactive. At each step, it generates the next shot, based only on what came before. You can change the camera angle, shift the lighting, introduce a new scene, and the story adapts instantly. But how do you maintain visual consistency across shots? Enter the dual cache memory. A global cache stores key frames from earlier shots for long-term identity. A local cache preserves motion continuity within a scene. And here's the genius. A row P discontinuity indicator creates a shot boundary signal, so the model knows when to switch caches. No ambiguity. No extra parameters. To prevent error accumulation, ShotStream uses a two-stage self-forcing distillation. 1. Train on ground truth history. 2. Simulate real inference, using its own imperfect outputs. This trains the model to recover from mistakes, just like a real storyteller. The results? On a 100-task benchmark. 0.825 intrashot consistency. 0.819 intershot consistency. 87.7% user preference for visual quality. It's not just faster, it's better. Running at 16 FPS on a single H200 GPU, ShotStream enables real-time cinematic prototyping, interactive game cutscenes, and live narrative experiences. This isn't the future of video, it's the present of storytelling. #5. Miro Eval, judging AI not by what it says but how it thinks. Finally, let's talk about trust. We've been judging AI research agents by their final reports, fluency, tone, polish. But that's like judging a scientist by their paper's font. We built Miro Eval, the first benchmark that evaluates how AI thinks. 100 real-world research tasks, from policy analysis to medical data, all grounded in authentic user needs. And it's live, evolving with real web trends and user queries. But Miro Eval goes deeper with 3 layers. 1. Adaptive synthesis quality, task-specific rubrics that check coverage, insight, clarity, even extracting facts from images and tables. 2. Agentic factuality verification. Every claim is checked across live web results and user attachments. Not just right or wrong, but conflict if sources disagree. 3. Process-centric evaluation. Did the system search widely? Reason critically. Trace every claim. We tested 13 systems: OpenAI, Gemini, Claude, Miro Thinker, and more. The results were eye-opening. A system with a polished report had low factuality. A cautious system had low synthesis. But the top performers, they were balanced, strong in process, factuality, and output. And the most telling insight: process quality predicts outcome quality. The top 3 systems on process were also the top 3 overall. Multimodal tasks were harder. Most systems failed to integrate visual evidence into reasoning. But Miro Thinker H1. It led in both text and multimodal, not dominant in one but consistently strong. Human verification confirmed. 92% precision, near-perfect agreement with automated results. This isn't just a benchmark, it's a diagnostic tool for trustworthy AI. Because in real research, the process is the product. This week we've seen a clear theme. The future of AI isn't about bigger models or more tools, it's about better knowledge, deeper reasoning, and smarter evaluation. Trace the Skill teaches agents to think like experts. FIPO gives them the ability to think deeply. Terminal agents prove that simplicity can be supreme. ShotStream turns AI into a real-time storyteller. Miro Eval forces us to judge AI not by its words, but by its mind. These aren't just incremental improvements. They're paradigm shifts toward autonomous, self-improving, trustworthy, and truly capable AI agents. And the best part? Most of this is built on open source models, open research, and open collaboration. So if you're building, researching, or just curious, go explore. Check out the papers, the code, the demos, all linked in the description. And if you enjoyed this deep dive, smash that like button, subscribe, and hit the bell because next week, we're diving into AI agents that write their own code, debug their own failures, and evolve without human help. Until then, keep questioning, keep exploring, and keep collapsing the future. This is Collapsed Latents. Stay curious.